Hello, and we are back at Tech Days Online, turning data into intelligence. And this time we need to actually think about getting the data into our device. And to help me do that, I'm joined by a very good friend of mine, whose name I bizarrely forgot a few seconds ago. He's going to kill me later. Andy Cross, MVP, and also another regional director, so sort of super MVP.
Oh, I'm not sure that's how we call ourselves, but certainly it's something that Microsoft like to, it's a different title they like to give us. Me and Richard both have that title, lucky enough to have that. It means, I think, that we get to talk maybe a little bit more about business rather than solely technology. I think
right.
It's sort of a different spin on it, maybe.
Okay. So, how are we going to ingest data at scale then?
Well, I suppose it really comes down to, you've got some data about your business, and the way I think about things is you've generated all this data and you want to get some insight from it. So you've got it maybe in existing silos inside your organization, they may be on disk, they may be in all kinds of different operational databases, warehouses, that sort of thing. And you want to apply some of the technology maybe that Richard spoke about earlier on, the at-scale analytics, but it's kind of in the wrong place for that, because if you're going to want to read those files, they have to be next to the compute that's doing the reading, otherwise it will spend all this time just streaming that data from disk across the internet into the cloud, and it's not suited to that kind of paradigm. So you just end up waiting for it to be ready before you can start anything, which is obviously no good. So we need to think about getting the data into the right place, and that's what the tools that we're going to talk about later on are all about, ingesting at scale. And internet scale is where we're interested. We first came to the cloud years ago off the back of things like the internet boom and people having enormous amounts of data requirements, compute requirements that really hadn't been around before. So we're talking now about maybe terabytes or petabytes or more of data that businesses have accumulated over years. And well, you can get data out of it using these great technologies that have already been covered to a degree, but well, how do you get it there? How do you get it ready? And that's, I definitely want to talk about over the next 45 minutes.
Okay, and we've got to kind of put it into production as well, I kind of guess, haven't we? So what, do I have to spin up some VMs? How do I get?
Well, I think that we want to try and stay as close to the platform as possible,
right?
With all the tools coming up here, right? So it wouldn't be a fantastically successful thing for the cloud to say, in order to store some data on disk, you need to spin up a whole bunch of VMs, and then you need to expose sharing services on those VMs, and then you need to use sort of the traditional on-prem kind of technologies for getting data into there. It would not allow you to separate out the concerns of storage from compute. So you'd have to keep adding more and more VMs every time you want to add another disk in, because you need the operator to manage it, despite the fact that all you're really doing is surfacing a storage area. So rather than the infrastructure services, the operating systems, and the more raw tin kind of like services, we really want to look at platform services, where storage is sold as a service.
Right.
And Microsoft say, use our cloud and just put your data in this space and we'll look after it for you. And, we do a really good job of looking after it. We'll make lots of copies of it, make it highly durable, make it highly available, maybe give it you in a cheaper environment or a more expensive environment based on whether you want to query it regularly or whether you want to use it for long-term storage. And there's lots of different options around there that we'll explore.
Okay. So let's get started then.
Okay, so I'll just quickly introduce myself. We had Richard on earlier on this morning, if any of the viewers at home have managed to catch that. So you've had two of the Elasticlouders, the founders, and we do data and consultancy in the cloud. We're based in London, and we're a Microsoft Gold partner. We're very closely with Microsoft in order to bring to our customers the great tools that Microsoft produce and put on the market. We also run a lot of community events at Elasticloud. A lot of people out there we've spoken to said they're going to watch, so I'm hoping that you are all watching the people from the UK Azure user group who probably never went to this URL, which I've noticed. It's the UK Azure use group. My R is in the wrong place.
Oh,
Bad R-ing.
That's why you're not getting people turning up to your events.
I know, I was the wrong URL.
But this Azurecraft thing, that was your idea, wasn't it?
So the Azurecraft, I think everyone's spoken about that so far, and there's been some videos about it. We've got Scott Guthrie coming over. We're really excited. He's a fantastic speaker who's spoken for us before. We're lucky enough for him to come over every so often and speak with us at the user group. And yeah, we're really excited about that. It's going to be a great event.
It's a testament to the relationship you have with us. I think you can pull him over. I suspect if I asked him to come over, who are you?
I'm not sure about that. You do all these things, and the bow ties alone. International star.
International star. Very kind. Very kind.
So shall we get on?
Yeah, we better get on. Yeah. We're in trouble otherwise.
So I wanted to just put a little bit of I know, slides, lots of text.
Lots of text, yeah.
Don't bother reading it. Okay. It's okay. No, so really what I wanted to do is just put this little bit of text out there. It came from Gartner, obviously a big consultancy, analyst consultancy, about what the future, the trends are in the market. And they said this in 2015 about the next couple of years. So it was kind of current last year into this year. And what they're saying is that really data's now got to a point in business where we're not just handling core data, we're not just handling data that a business owns. What we're doing is we're really enriching data with additional data sets that may even come from third parties in order to enrich and give ourselves an insight from a different perspective on what the data we hold about our customers. Did people buy shoes when it was raining, for example?
Weather's massively important, isn't it? I mean, in all sorts of areas, and very few people are capturing that. And then you've got, obviously, everyone talks about social media analytics and all this kind of thing, and maybe that's becoming a bit passé, but nonetheless, we're not normally capturing that kind of information.
Yeah, and it's interesting as well, because if you're running an e-commerce company and you're interested in why shoes are selling particularly today, you're not necessarily interested in what the weather was on that day when you look back historically. You can also be interested in what the forecast for the weather was going to be and what the forecast for the next weekend was going to be at that point in time. Because when people receive the forecast, that informed their actions.
Not actually what it's doing on the day.
And maybe it did rain instead, but people still went and bought shoes. And why was that?
And then you've got this business-to-business angle as well, I think, where, if you're selling, I don't know, beer or something, you're not directly selling, you're selling it through partners, so it's going to be in the big supermarket chains, online and what have you, and so you need to aggregate that kind of data. That perhaps is a traditional problem, but nonetheless is still a hard problem to crack. It hasn't gone away.
Yeah, and I guess what the real issue is, why this context is useful, is that really the data in silos in businesses, on-prem, in your own data center, that's kind of how we were where we came from. We move it up to the cloud, and in that process you get the access to additional tooling, additional type of analytic horsepower, raw compute as well as better tools, like the data lake stuff, the HD Insight stuff that we've mentioned already. But it's that process which involves bridging the gap between the on-prem data silos that you've generated in the past and the new place that you're going to go and do analytics. And that is one of the reasons, the key reasons, to start ingesting the data in the cloud. So, I mean, you kind of have these two paradigms, don't you? You've got data that's born in the cloud. So you're a business which has adopted, this might be a growth area for the future. You've adopted the cloud, you now run your websites in the cloud and all of your line of business apps in the cloud. So when you put your logs to disk or to storage, it's actually going into a cloud store at that point. It never has to really be ingested. But at the moment, a lot of people are moving. I've got all these logs on the site, I want to get some value out of them. Now I have to move into the cloud. So it's a very common challenge that we face all the time with lots of our customers.
And you could have the onboard ERP system, but you are, some of the data is still on your internet-facing site, and you're trying to stitch that together. So these have been around before, but I also think you've alluded to the fact as well that there's data that traditionally we'd have just chucked away because we didn't think it was relevant. For example, how are people navigating through our websites? So if we understand that, what clickstream analysis kind of thing, that could be important.
Yeah, absolutely.
And picking that apart to see if a website design change has actually influenced sales in the way that we anticipated.
Yeah, absolutely. And when we start thinking about doing statistics, there's some sessions coming later on about R, which will be quite interesting. When we start talking about machine learning and things like that, that's all great. I mean, but they all rely on the data being available to those algorithms. So what we might have to consider first of all is cleansing our data, or some process of getting our data up there in the first place. And I really want to explore what those are so that the later sessions can have a bit of a context, say, well, I've got my data in that place now. A lot of people will have this problem domain. Okay, so how do we get our data to the cloud? We've probably started in a situation where We've tidied our bookshelves, as it were. That's the slightly
Is that
terrible
at home?
method. That's not my office. No way. No way is that my office. That would, they'll probably be on the floor, and there'd be an empty bookshelf next to it. I just never got around to doing the stuff. But we've got our sort of books all aligned. We've tidied everything up on-prem, and then we have to move things up to the cloud. So what's the process, or the thought process we have to go through early on? We end up with a pretty simple 4-step process that we work on, which is cleansing to start with. Make sure our data is clean, because we don't want to take duplicates up into the cloud. We don't want to take malformed data up in the cloud, because there's a few good reasons for this. You pay per byte stored, effectively, or maybe it's united per gigabyte, but you're paying for usage. So having 2 copies of the same data is doubling your costs when you move up to the cloud.
Especially as we've already, Microsoft or whoever the cloud provider is, are taking care of that resilience for you.
Absolutely.
So you storing 2 copies is a complete waste of time. We're doing that.
Yeah, absolutely. So you want to take it down to the core data. You want to get rid of the backups, the old data. You want to move away from having lots of various versions of it, and combine it as much as possible, so that you've got a simple to transfer data set that just relates to the actual interesting information that you can then go and mine. Okay, so the first step always has to be data cleanse, and I think we've always had data cleansing steps in most of our traditional data warehousing technologies. It's nothing new, but what it is interesting is that at this point we breach a technical gap. We sort of go from on-prem to the cloud, and we also transition between 2 models of economy. So previously you bought capacity, and if your data fit in it, that was it, there was no additional cost. But then the new economic model inside Azure and all the clouds is pay per use. So if you do take lots of copies of the same data up there, you're paying just time and time again for it. So it becomes extra important to cleanse, to get rid of the dedupe, but also to enable the analytics to work without first having to do an analytical process of cleansing in the cloud. When you're close to the data, and you've got the maybe the people who are saving the data, the domain experts of the database at that point, that's a really good stage to just trim out things that are irrelevant, trim out things that are maybe historic, that are no longer used, that are legacy data, to just tidy up and convert data types that are maybe just broken in the database. All of this stuff on-prem before it moves to the cloud, if possible, is definitely some mental process you should go through.
Right.
Following that, we have to think about the staging, right? So how do we get it into a format that allows us to lift it up into the cloud? Now, for me, and for the rest of the talk, I'm going to consider primarily files. Okay? So lifting up operational data and putting operational data into the cloud is possible, and you can have all kinds of technologies out there that do that. But really, when we're talking about analytical process that we're really looking at for the majority of our insight, they work over the top of flat files. Hadoop, flat files in, flat files out. Same with Spark, same with NoSQL. Typical sort of workloads are to take an extract of a database, to take almost a backup, although outside of the proprietary format of the data stores themselves, into something more common. You might consider that to be a CSV format or something like that. A CSV format, comma-separated values, it's something which is incredibly easy to understand. There are some better formats out there that maybe include the schema alongside the data.
JSON.
JSON was an example of something, maybe BSON, if you want to go with a bit more compression. It's like a binary version of that. Then there are things that have come from the big data world, like Parquet format, and there's maybe protobufs that Google put out, and Microsoft have got a Bond format, and there's lots of different versions. I know, great name, right? The bow tie like that.
Yeah. My name's Bond.
And so there's definitely a stage where we take out of an operational store and we put it into a file, right? And it seems a bit old school maybe, but you know what? That file is going to be super useful moving forward. Now that preparation stage, you might well change a few types. We might take a date time and convert it into an easy to understand string, for example. An ISO formatted string. We might converge on the same sort of format. So then later we can do ranges, make it a numeric rather than a string. But, there's lots of things that we might do in this stage, but it ends up having a file which is available for us to do something with later. Then we do the real thing, the actual data transfer. This is lifting that file up, pushing it over the internet somehow, or pushing it over the boundary of the data centers. And it starts in data center A, which is probably on-prem, could be another provider, could be, you
Yeah.
might have put it on Dropbox or Box or OneDrive, or well, you might have put it somewhere like that. And it leaves that data center environment and ends up in another data center environment, which is going to be Azure for the rest of the session at least. And so that's a data transfer piece where we just lift and pop it down somewhere else. And the final thing to then do is to run the analytics over the end of that, is actually get the value out of that data. We have to do something with the data. We can't just leave it there and expect data to insight and magically fall out of it. It won't happen. So what do we do? How do we do that? And how can we do that in such a way that maybe the data transfer or a data stage or something is going to trigger those analytics? How can we do that in a pipeline in such a way that we have a continuous execution? We can almost trigger off jobs to run. Because that's going to mean new data is available, new insight is available, which is a good, valuable proposition.
So obviously you've got this initial thing we've been talking about, tidying up, moving a big chunk of data to Azure. But then we're going to continue to generate data, and then we need that production process every night, hour, whatever. The classic ETL of my youth of this process that we want run every night. And of course that could be incredibly fragile. And the network's broken, the service that spat the file out isn't there, and so then you come in the following morning and you want eyes on to work out what didn't load. You don't want to load the same file in twice. You want to make sure there isn't a gap. And all that kind of problems, and before you start to get to the analytics piece, because otherwise you're going to end up with garbage out. And before you put it into its final resting home, you want to be super clear on that, because otherwise you're going to corrupt the information you perhaps have there already.
Yeah, I mean, garbage in, garbage out is the old adage, right?
Absolutely,
and you can't really fix that so much with even with these processes. You might have more resilient processing technologies like to retry things, but if there's a problem in a piece of data, there's not so much you can do with it. Maybe with semi-structured technologies, you can work around missing fields or something like that. But if you are building an integrated stack, an integrated system, you probably have the opportunity further up the stack to fix those problems.
That more meant that we might miss a whole night's load, or we'd end up with duplicating or something like that. That overnight process has somehow damaged the system rather than inherit problems in the quality of the data.
And then to the orchestration of that, picking up that file regularly, catching up when the network is restored, all that sort of stuff. We should have a platform in place that allows us to do that. Okay. We should really think about the cloud storages, though. There are multiple cloud storages, and you guys like to make it harder for us all over and over again.
We're evolving. I mean, we're always, perhaps the most common word you'll hear a Microsoft person say is "it depends" on what you want to do. And so for me, I think traditionally we started off with blob storage, chuck anything in there, and then allied to that we have table storage, which gives you a bit more structure. Then you end up with databases, data warehouse, which are super structured. But then coming in from the left here, we were just talking about this with Alan, that we have this situation where, and Richard, that blob storage of itself wasn't designed to do what we're trying to do with it when it comes to big data. So then we brought in this data lake storage
absolutely.
play.
So both of these are oriented around unstructured data, right? You might have structure implicit in the files, but the technologies themselves are just files that can contain anything. It's not going to say you can't save this file because you haven't got a comma or you haven't got
absolutely.
It's going to let you save everything in both of these, whether it's an image, a video, a text file, anything.
And indeed, Azure Blob Storage is the home for our virtual hard disks when we're running those VMs that we're trying to get rid of.
Absolutely. Absolutely. So if we think about these two main places, the Data Lake Store and Blob Store, you do have the ability to do analytics over the top of both of them. And really, though, it comes down to the Blob Store being first, the Data Lake Store being second. It was built for a reason, right? So there was a reason that they didn't just stay with having Blob Store as the only storage mechanism. There were use cases where it could be optimized, and then the Azure Data Lake Store became that optimization that was available as a product. And the optimization is around analytics, right? That's the core. It's called Data Lake, which is a broad marketing-y sort of term.
But it's a real piece of tin.
But it just describes throwing stuff in and going fishing later, right? And that idea of just building this enormous store of data that then you go and get insight on is absolutely fine. But what you need to do is have very fast capacities for reads over this large amount of store that you can't really have artificial limits on. And there were some artificial limits around blob storage, about size of files, the amount of files you could have, like 500 terabytes that you got to, which is a large amount, a very large amount of data. But it's not the hyperscale that the Azure data lake is built for, where petabyte files are allowed, and you're allowed to have many of those inside a storage data lake store. So you can have exabytes in total across it. It's a different order of magnitude increase in the capacity of what you can do with a data lake store. And I think inside the data centers, it's the same fundamental technology. It's not like you went out and invented a whole new type of storage subsystems. It's a clever partitioning, clever storage approach on top of the same sort of fundamental building blocks.
And we haven't got it on here, but obviously both of these are addressable from are HDFS compatible. That's kind of what I wanted to. That's probably your next slide. And you're going to
not on the next slide. Maybe later on. But they're both compliant in effectively de facto standard for analytics, which is HDFS, comes from Hadoop. Inside Hadoop itself, in Azure, we're talking about HD Insight, or the Azure Data Lake clusters. And this technology wraps Hadoop. It's the Hornworks distribution of Hadoop. And one thing that Microsoft have done to extend that is to plug in a Hadoop file system called WASB, or WASB. And then it means you can then address a file, any input location that you give to Hadoop. If you give it the scheme, which is a part of the URL before the ://, if the scheme is WASB, it knows to use this Microsoft implementation, which goes against blob storage. So underneath, blob storage is all HTTP, all the way through. It's a HTTP-oriented protocol. So it's a transition between, or a translation between what Hadoop expects to read and what blob store is capable of doing. So it's a piece of custom code that runs inside Hadoop. With the data lake store, it's totally different. Different approach was taken, and it's web HDFS. And it supports web HDFS so that you don't have to have this custom piece of code inside HD Insight. Anything which can natively read web HDFS, which is all kinds of different types of data technologies, including Hadoop and including Spark and including lots of different things that are out there in the open source world, can natively connect to the data lake store and just be like, oh, it's a web HDFS endpoint, cool.
So if we were doing the sort of spawn of Satan and saying, I'm going to spin up a cluster of VMs for my particular big data solution that's based on this, they'll be able to go against this data lake store, and I could architect my own cluster and do my own compute against it.
Yeah, absolutely. So if you wanted to invent your own technology for data analytics, maybe call it Brisk. That'd be a good name, and then you would write lots of stuff and connect it in and look for a common pattern to connect lots of different technologies. That would now be web HDFS, and you would be able to access it from many different types of technology.
Okay, so we've got somewhere to stick it.
Yep, that's where it's going.
We know what we need to do with it.
Yep.
How do we get it there?
Right. How do you get your stuff there?
So
is it on those floppy disks?
Well, there was a South African girl I met who called that a stiffy, because the bigger ones were called floppies, the 5 1/4 inch ones. Just a bit of cultural diversity there for you.
I've learned something.
You've learned something, yeah.
I wish I hadn't.
I've probably got some of those. I've probably got some of those at home. I should have brought some in with me.
Okay. So if we wanted to let's think about our petabyte of scale.
Yeah.
Okay. Let's think about our file, which is a petabyte. If we had to span it over these diskettes, there's going to be quite a few. How many? Deloitte did a study on this, and it was
that's good to know.
Yeah, 746 million floppy disks for a petabyte.
Okay.
Which is a lot, and it equates to, it's so many, it's no use. Like, because if a petabyte's hard to imagine, 746 million floppies is also really hard to imagine. But it equates to 13,000 tons, and that's the same as the HMS Duncan, which is a British destroyer.
Okay, right.
So it's big.
Yeah, that is big
data. If you can turn it to metal, that's what you can get out of it. Yeah, okay. That's a petabyte of data if you put it on those. Okay?
Okay.
So we're talking about a lot of stuff, and we need to have a very robust process to get it there.
Right.
If we want to take the offline route, we can go hardware transfer into the data center.
Yeah, send us a disk and...
Yeah, absolutely. So, we've got a massive collection of data. We can put it onto terabyte-sized disks instead of 1.44 megabyte-sized disks. And maybe we need a handful of those, maybe we need a truck full of those.
Yeah.
But you can get it on those pretty quickly and you can ship it off. And the service is Azure Storage Import Export. And they give you secure sort of BitLocker kind of keys that help you encrypt the disks so that only Microsoft can decrypt the data that's on there and then use their fast backbone within the data center to pull data off there and rehydrate it into blob store.
Yeah.
So if we want to get our data in, we can physically ship stuff. Right? It's something we've seen done. It can be very, very fast because you bypass the fundamental limits of uploading into the data center. Right? So we've had some customers of ours who have done very fast ingestion into the Azure data centers, and they've done that through having machines that run things in parallel, having dedicated fiber going in, so having an express route connection into the Azure data centers, and then dedicating it all to the upgrade process. And we've managed to get it to about 4 terabytes a day of sort of upload. So it's quick, but it's not super quick. And if you've got a 5 terabyte disk and you can ship it somewhere, it's going to get there possibly quicker if you use the service than if you upload it.
Gotcha.
Right?
Yeah.
But if you have things running in the background all the time, the import-export service is possibly not the way to go. You could also probably turbocharge the data way beyond that 4 terabytes a day limit if you put multiple express routes in there, if you basically spend a bit longer and maybe a bit more money beefing up your connection into that Azure data center.
Yeah.
So and there's probably going to be ways in the future to speed all that up as well, I would say. But if you were to do that, what you can do is ship your stuff up. That's absolutely fine. The other way of doing it, if your data's already there and you want to ingest it between data centers, you can just use an Azure storage container's geo-redundancy to access it from a different location, which is a way, if your data is born in the cloud, is a way of you accessing it from a different location within maybe the same geo-region, but North Europe and West Europe, for example, Amsterdam and Dublin, you could have your data being written in Dublin, and it would just magically appear through geo-redundancy in Dublin. It would be a read-only copy there, and you'd be able to do your analytics at scale there as well, should something go wrong with there. So I just wanted to sort of say that if your data is born in the cloud, you have different options that are emergent because your data is already kind of in the right place, but it's not necessarily the only place you would want it anyway.
Okay.
So if that's the offline approaches, which are maybe a little bit dull, we maybe want to consider doing data ingestion at scale with an active metaphor. And what I mean by that is throwing a bit of compute at the network so that we can pull files across the network. And this is digging now into this network-connected 4 terabyte a day kind of approach. How do we get, with a network-connected on-prem system and a network-connected cloud system, how do we get that data over there, over the internet? Whether it's public internet or private route going across internet protocols through express route. If you're looking to use the Hadoop ecosystem, because maybe you're going to run HD Insight analytics and that's what your team is skilled in, you can simply spin up a HD Insight cluster, and then you can use this thing called distributed copy, DistCP. Right. And that's a Hadoop core function that is built right into Hadoop, and you give it a set of command lines, command arguments, like files that you want to move from A to B, and you tell it where it can go and address that. And if the endpoints are addressable by a Hadoop, it can go and move things around for you using the Hadoop cluster, not to do analytics, but to do raw compute. So you might say to it, go and read from an internet URL, go and connect to an on-premises Hadoop implementation via Web HDFS maybe. And as long as Hadoop can resolve those two endpoints, it can read from one and push to the other. Now, inside of Azure, you can use this approach to copy from blob storage to Azure Data Lake Store. So you spin up a HD Insight cluster, and you say your primary Azure blob storage, the WASB connector, goes against a storage account with blobs in it. And then you say there's an additional store attached to this this Hadoop cluster, which is the Azure Data Lake Store. So then it's got both of those configured for that cluster. And then you use distcopy to say from the blob store to Data Lake Store, and the other way around too.
Sure.
if you wanted to take things there. So
Yep.
you can see that pattern using the Hadoop nodes to do the work.
Right. Gotcha.
If you want to copy onto the data lake store, you can use ADL copy, which is an executable you can get from Microsoft.
Yeah.
And you can use that to either in a standalone mode pull the files in from a local location where you upload to it, or you can get it to move things, again like Hadoop, between two well-known endpoints using Data Lake Analytics as the runtime. So you can get it to use that instead of Hadoop's data nodes. You get to use the Data Lake Analytics data nodes to do the work.
Gotcha.
instead. Then you can, if you want to get things onto Blob Store and they're existing locally, this is often how you start, and this is often the first thing you do in this process. You use this thing called AZ copy, or AZ copy, and it's a command line executable which allows you to specify a local disk location, a remote blob location with a key and a container name and all that sort of stuff. And when you run it, it will in parallel copy all the files up there. You can also use it to copy between blob containers, so if you or blob storage accounts. So if you've stored it all in the wrong storage account, for example, and you need to transfer some people to this, you can move them across. If you want to do manual backups, again, you can do that. You can use AZ copy to say go across from A to B. And the approach you can do, the approach that uses to do inter Azure containers copying is called the async blob copy, which is a feature of Azure Blob Storage. So Azure Blob Storage comes with blobs, tables, Azure Storage comes with blobs, tables, queues, files. It also comes with a service that is very rarely used, it's the async blob copy service. It's baked into the blob side of it, it's got a blob endpoint, but it's actually a runtime service. It's not just about storage, it's about addressing files that are on a blob store or on any public HTTP endpoint that it can address, and sucking it from that HTTP endpoint and outputting a blob. So if you've got a file with an access signature on it, maybe a Dropbox kind of file or OneDrive file, or any kind of internet internet location, and you give it to the blob copy activity, it will download it for you and save it directly as a blob, which is really helpful. And all you need to do is have it publicly accessible, and it's great. The kicker is that it's async, right? So it happens in the background. It's asynchronous. It's not something there's an SLA baked in on top of. It's something that is queued by Microsoft as bandwidth is sort of available inside the data centers and happens outside of your control. You can't say this is a high priority copy, I want this done in the next 2 minutes and I'll pay you more money. Those aren't services that are baked into it.
No, because it's really, Azure is like, for the most part, you're not being charged to ingest data, you're being charged to store it, but it's only when you egress data that you would incur a cost, perhaps.
And this particular copy technology is there as a helper to get your data in and maybe move it around within the data centers. It's not there to be something which is core business critical. So that's why there are things like the Hadoop options and the ADL copy options that allow you to use a compute cluster that you've spun up that you're paying for to go and do the work, because you can scale that Hadoop cluster out, you can use more units of Azure Data Lake in order to go and ingest more data from the endpoints that you give it to go and do. And if you think about what that's happening, you've got all these machines that are living inside a cluster that are all managed for you, and each of them is given a job, go and download that file and store it here, go and download that file and store it here. And that's what that thing does. And because you're paying for the machines, and you can add more in, you can use fewer, you're in control of the SLA around that then.
Gotcha.
And then the last option you've got of actually actively putting stuff into Azure is manually going and creating either blobs or of manually going and creating the data lake store files.
And just going into Visual Studio or whatever and copying them up
Visual Studio, the SDKs are all available. There's
PowerShell, whatever it is.
There's options for people who are using different operating systems too. So if you look at maybe you're on a Mac, the Azure command line, the cross-platform Azure command line.
Azure CLI.
It's got Azure. You type Azure and it gives you all the options that are available. One of them is storage, and then there's blob, and there's upload. So you go Azure blob store upload, give it a file name, and then give it some keys, and it will handle all the auth for you and just upload a file there. And that's cross-platform. It will work on Macs and Linux and Windows. Okay, so that's a pretty cool approach for you that's baked in. But if you're using maybe a different programming language, you're in PHP, you're somewhere else, you're in Node.js, these have all got SDKs available to you as well.
Yeah.
Okay, so, but what do these things do, right? So it's a file to blob store in idle copy, and it's a AZ copy goes to blob store, right? So this is the interesting thing. If you want to get a nice, easy approach from into Azure Data Lake, what you tend to have to do is copy it via a blob endpoint and then into a data lake endpoint if you do it at the command line.
Oh, okay.
So you end up having to use two tools and staging it at a blob endpoint because the AZ copy has got a better approach to storing the files as blobs, and the idle copy doesn't really let you say, go and get a file from my local disk and put it on.
Okay.
AZ copy does. AZ copy says, I've got a local file, put it as a blob, and then ADL copy says, you've got something on blob, put it on ADL.
Okay, so we're back to our copying kind of thing again. So we could be paying twice if we're not careful about tidying up after we've got it all in there.
Absolutely.
So there's got to be a better way than this.
There is. We'll get to that right now. So you can use the Azure Data Factory.
Right.
So I imagine we might have mentioned that already today during the course that we haven't.
Not really, no.
Oh, wow. Okay.
Well, a little bit. I mean, only that it exists and that it's out there. I mean, Alan we were talking about sort of putting stuff in at scale.
Yeah.
But so, yeah, I mean, obviously, when people may have seen an Azure Data Factory demo, if they've gone and looked at it on the Azure portal, it's typically you're uploading a file to build a lab, but what we don't perhaps go into is that thing that you put down there, that Data Factory Management Gateway, which is, because not everyone's going to have their data. For some reason, people don't like exposing their data to the internet, Andy.
Well,
so
the thing,
we need to do that securely, right?
Yeah.
And this is what that thing does, I'm guessing.
Yeah, and if you go and look at any of the Data Factory labs, I imagine they start with a blob that's available in blob store already.
Yeah. Exactly.
And then they'll focus on, so your data's there, now let's do something fascinating with it. And it's worth just touching about what that is. Data Factory is probably the most important data technology in the entire Azure data platform because it's the king. It's the thing which can call in to every other minion service on Azure's data platform. It can call into HD Insight and say, run this job. It can call into Azure Data Lake and say, run this job. It can call into machine learning. It can say, they've all finished now, so let's pick that file up and put it in Power BI. Right? It can be the orchestrator which actually embodies the business process that you're actually using the cloud for in the first place. So it's the really top level, super important thing. And people often come to it after they've solved maybe part of the process and they want to then automate it.
Yeah.
Well, I would say probably, if you haven't come to Azure yet for data, you should start at the Data Factory.
Yeah, so it's the whole POC thing. I'm just going to sling the files in there. I'm in Visual Studio. Let's just get some sample data in, and then the light begins to dawn that you need to load this up from wherever it is every night.
Yeah, absolutely. Yeah. And so the Data Factory team produced something called the Data Factory Management Gateway. You install it inside your corporate firewall, so on your machines in your data center.
Yep.
And it uses just HTTP access outbound, so you don't have to do too much around the corporate firewall. It's kind of lightweight when it comes to that. It uses the Azure Service Bus, maybe a couple of ports you have to open for that, but they're well known, and that's its command channel. And it receives commands from the Azure Data Factory to say things like, find me the latest file which has been created in this location, and if it's different from the one I was expecting, copy it up, send it up to me. And it manages that whole process.
Wow, okay. So it's not just a way of punching through a firewall, it's more than that.
No, it's got a little bit more complexity to it than that. And but you can look at the broader sense and think, well, that is the service it provides. It's a way of punching through and getting a tunnel opened up so that you can then transfer securely over the internet and have your on-prem data then available to your analytics moving forward.
Right, so that is kind of what we want to do. I guess there's some bits and bobs here. How do we make one of these?
So you use JSON to define the type of pipeline. You have pipelines and activities. The pipeline describes many activities in a sequence, which is something like first copy my files, then go and run some analytics on those files, and then at the end of the analytics process, lift the result into something like Power BI.
Yeah.
Now that process, that's defined as a pipeline has many of these activities in there. One of the activities that is really core to what we're talking about, the lifting of data and putting it down. That's the copy activity, which copies the files from a source into a destination which is on Azure. Now, that is defined as a bunch of JSON. There's a nice new wizard, which unfortunately I didn't get a screenshot of. I wish I had. But there's a wizard inside the Azure portal. You just go through and say new data factory, and then you say you can create a new activity, which is a copy activity, and it takes you through a bunch of steps, which include, if you've got a management gateway in place, you can connect to it, you can tell it and configure it, and then you can just have the pipeline executing on the schedule for you.
Right. And how do I? So you talked about JSON.
Yeah.
And I've got a wizard to copy. How do I? Where do I put all this code? How do I actually code against Data Factory?
So you can create a bunch of JSON files on disk, and if you really want to, use PowerShell to push them up to Data Factory itself. Okay. Or there's like an integrated wizard, an integrated designer that exists inside the Azure portal, so you can just go and do all the work in there.
Okay, yeah, and my favourite preferred technique is to use that Visual Studio thing.
Oh yeah, yeah,
so
absolutely.
And you can get an add-in, and then you can, if you've already employed an Andy Cross to write your Data Factory for you, think, right, genius, that's he's done the POC for us, right, I'll have that, check that out into Visual Studio, and then you could fiddle around with the connection strings and to maybe the source and targets. And then deploy it to a new Data Factory that's going to be your production copy as a whole solution.
And they all interop through the underlying technology, which is JSON encoded.
Yeah, you see all the encryptors there. And then obviously, if we've got that thing in flight, then we kind of need to have this repeatability built.
Yeah, absolutely. And that's one of the key things that the Data Factory will do for you. Run these things overnight, run these things regularly.
Fantastic.
It has this concept of a linked service, which I really like, because it brings the notion of a transient cluster to life. You actually only want a HD Insight cluster running when you're doing your analytics.
Yep.
After that, you want it to go away because it costs you money to have running.
Right.
So a linked service defines a HD Insight cluster that's called this. It's got this username and password. It's connected to these storage accounts. But they can be just a standard permanent type, or they can be a transient type that's created for you, an on-demand cluster created by the Data Factory itself, executes work on that cluster, and then when it's finished, it will turn off that cluster for you. So you only pay for the duration of your query itself.
Genius.
Yeah. So as a data pipeline, it really works well.
Yeah. And for people who are terrified of JSON, as we run out of time, it's probably worth also mentioning that we know it's in the works. It's not there yet, but when you create a Data Factory, you get a nice visual diagram of what it looks like. But imagine for a minute if you could draw the diagram using the tool, and that is on the roadmap.
Yeah.
And it's important with all the services we're talking about today to check back regularly. We probably need to get Andy back on the couch in a few months' time, because this thing will be in play. We'll need to re-record this on Channel 9, because you've got to constantly revisit what's going on up there. And that's one way around. The other way around, of course, is if you don't like what you see, and I know you do this a lot, Andy, is to go on there and register for things that you'd like us to change. We are listening. It's not...
user voice is the place to go, right? So
yeah, and you can see what's coming down the track as well. So if you're feature, you can vote up stuff and promote stuff and all this kind of thing. So that's super useful. So this Data Factory, you spend most of your time in, I guess. Yeah,
as I say, I consider it to be the king of the data platform.
Yeah, we're going to hear that a few times from different people today, I think. They might have a slightly different perspective than you. But I do get your point. And in my world, we've been talking about advanced analytics. We heard from Matt Smith, and he was talking about, retraining. The algorithms. Well, Data Factory will do that for us.
Yeah, absolutely. So you have connectors that go into machine learning, the Azure machine learning service. Yeah. But also you have connectors that go into custom code that you can do whatever you want in there.
Right. And the custom code, though, is coding against the object, the compute service you're talking to. So if you're talking to an HD Insight cluster, the custom code might be an HQL script.
You could do, you can do that, and you can run any kind of .NET code through an SDK that they package too. So you can actually extend what the Data Factory is capable of doing itself.
Yeah, and so just to be finally clear, as we run out of time, this thing is not like integration services. It's an orchestration engine. It's not doing the work itself. It's telling other things to go and do things.
Absolutely.
And I think we need to be really, really clear on that.
Yeah.
Andy, I think we need to get you back again on the couch for the next one of these.
I've had a lot of fun.
thank you very much for your time. And we're going to take a short break now. And hopefully next up we've got Paul Foster, I think, doing some clever stuff with IoT.
Doesn't surprise me, he's a very clever man. Have a great time. Services, the operating systems, and the more raw tin kind of like services. We really want to look at platform services, where storage is sold as a service,
right?
And Microsoft say, use our cloud and just put your data in this space, and we'll capture it for you. And, we do a really good job of looking after it. We'll make lots of copies of it, make it highly durable, make it highly available. Maybe give it you in a cheaper environment or a more expensive environment based on whether you want to query it regularly or whether you want to use it for long-term storage. And there's lots of different options around there that we'll explore.
Okay, so let's get started then.
Okay, so I'll just quickly introduce myself. We had Richard on earlier on this morning, if any of the viewers at home have managed to catch that. So you've had two of the Elasticlouders, the founders, and we do data and consultancy in the cloud. We're based in London, and we're a Microsoft Gold partner. We're very closely with Microsoft in order to bring to our customers the great tools that Microsoft produce and put on the market. We also run a lot of community events at Elasticloud. A lot of people out there we've spoken to said they're going to watch. So I'm hoping that you are all watching the people from the UK Azure user group who probably never went to this URL, which I've noticed. It's the UK Azure use group. My R is in the wrong place.
Oh, yeah.
Bad R-ing.
That's why you're not getting people turning up to your events.
I know. I was the wrong URL.
But this is Azurecraft thing. That was your idea, wasn't it?
So the Azurecraft, I think everyone's spoken about that so far, and there's been some videos about it. We've got Scott Guthrie coming over. We're really excited. Is a fantastic data into the right place. And that's what the tools that we're going to talk about later on are all about, ingesting at scale. And internet scale is where we're interested. We first came to the cloud years ago off the back of things like the internet boom and people having enormous amounts of data requirements, compute requirements that really hadn't been around before. So we're talking now about maybe terabytes or petabytes or more of data that businesses have accumulated over years. And well, you can get data out of it using these great technologies that have already been covered to a degree, but how do you get it there? How do you get it ready? And that's, I definitely want to talk about over the next 45 minutes. Okay,
and we've got to kind of put it into production as well, I kind of guess, haven't we? So what, do I have to spin up some VMs? How do I get?
Well, I think that we want to try and stay as close to the platform as possible, with all the tools coming up here, right? So it wouldn't be a fantastically successful thing for the cloud to say, in order to store some data on disk, you need to spin up a whole bunch of VMs, and then you need to expose sharing services on those VMs, and then you need to use sort of the traditional on-prem kind of technologies for getting data into there. It would not allow you to separate out the concerns of storage from compute. So you'd have to keep adding more and more VMs every time you want to add another disk in, because you need the operator to manage it, despite the fact that all you're really doing is surfacing a storage area. So rather than the infrastructure.
Hello, and we are back at Tech Days Online, turning data into intelligence. And this time we need to actually think about getting the data in to our device. And to help me do that, I'm joined by a very good friend of mine, whose name I bizarrely forgot a few seconds ago, who's going to kill me later. Andy Cross, MVP, and also another regional director, so sort of super MVP.
Oh, I'm not sure that's how we call ourselves, but certainly it's something that Microsoft like to, it's a different title they like to give us. Me and Richard both have that title, lucky enough to have that. It means, I think, that we get to talk maybe a little bit more about business rather than solely technology. I think it's sort of a different spin on it, maybe.
Okay. So, how are we going to ingest data at scale then?
Well, I suppose it really comes down to, you've got some data about your business, and the way I think about things is you've generated all this data and you want to get some insight from it. So you've got it maybe in existing silos inside your organization, they may be on disk, they may be in all kinds of different operational databases, warehouses, that sort of thing. And you want to apply some of the technology maybe that Richard spoke about earlier on, the at-scale analytics, but it's kind of in the wrong place for that, because if you're going to want to read those files, they have to be next to the compute that's doing the reading, otherwise it will spend all this time just streaming that data from disk across the internet into the cloud, and it's not suited to that kind of paradigm. So you just end up waiting and waiting for it to be ready before you can start anything, which is obviously no good. So we need to think about getting the speaker who's spoken for us before. We're lucky enough for him to come over every so often and speak with us at the user group, and yeah, we're really excited about that. It's a great event.
It's a testament to the relationship you have with us. I think you can pull him over. I suspect if I asked him to come over, who are you?
Oh, I'm not sure about that. You do all these things, and the bow ties alone. International star.
International star. Very kind. Very kind.
So shall we get on?
Yeah, we better get on. Yeah. We're in trouble otherwise.
So I wanted to just put a little bit of slides, lots of text.
Lots of text, yeah.
Don't bother reading it. Okay. It's okay. So really what I wanted to do was just put this little bit of text out there. It came from Gartner, obviously a big consultancy, analyst consultancy, about what the future, the trends are in the market. And they said this in 2015 about the next couple of years. So it was kind of current last year into this year. And what they're saying is that really data's now got to a point in business where we're not just handling core data, we're not just handling data that a business owns. What we're doing is we're really enriching data with additional data sets that may even come from third parties in order to enrich and give ourselves an insight from a different perspective on what the data we hold about our customers. Did people buy shoes when it was raining, for example?
Weather's massively important, isn't it? I mean, in all sorts of areas, and very few people are capturing that. And then you've got, obviously, everyone talks about social media analytics and all this kind of thing, and maybe that's becoming a bit passé, but nonetheless, we're not normally capturing that kind of information.
Yeah, and it's interesting as well, because if you're running an e-commerce company and you're interested in why shoes are selling particularly today, you're not necessarily interested in what the weather was on that day when you look back historically. You can also be interested in what the forecast for the weather was going to be and what the forecast for the next weekend was going to be at that point in time. Because when people receive the forecast, that informed their actions.
Not actually what it's doing on the day.
And maybe it did rain instead, but people still went and bought shoes. And why was that?
And then you've got this business-to-business angle as well, I think, where, if you're selling, I don't know, beer or something, you're not directly selling, you're selling it through partners, so it's going to be in the big supermarket chains, online and what have you, and so you need to aggregate that kind of data. That perhaps is a traditional problem, but nonetheless is still a hard problem to crack. It hasn't gone away.
Yeah, and I guess the real issue is why this context is useful is that really the data in silos in businesses, on-prem, in your own data center, that's kind of how we were where we came from. We move it up to the cloud, and in that process you get the access to additional tooling, additional type of analytic horsepower, raw compute as well as better tools, like the data lake stuff, the HD Insight stuff that we've mentioned already. But it's that process which involves bridging the gap between the on-prem data silos that you've generated in the past and the new place that you're going to go and do analytics. And that is one of the reasons, the key reasons, to start ingesting the data in the cloud. So, I mean, you kind of have these two paradigms, don't you? You've got